Okay, so this is lesson 4, part 2. We're ready to learn how to multiply together these matrices. Now, we know from the calculator that the answer to this question here is this thing, 158, 64, 139, 154. Let me show you how you get that. As a refresher, because this is a 2 by 3 matrix and this is a 3 by 2, that means they can be multiplied together. And the dimensions of the answer is going to be these outer numbers 2 by 2. So that's why we have these 4 slots here. To get the number that's in row 1, column 1, that's this element right here. To get that element, we take row 1 from the matrix on the left and column 1 from the matrix on the right. And we do kind of a funny thing. We multiply 1 times 7, we multiply 2 times 9, and we multiply 3 times 11, and we add those 3 answers together. And it's 58. And that's the number that goes there. So I put the 1, I multiply the 1 by the 7, I move to the right here, so the 2, this one goes down, multiplied by 9, and 3 gets multiplied by 11, and that goes there. To get this top right element, which is row 1, column 2, I do the same thing, but this time I use row 1 in the left-hand matrix and column 2 in the right-hand one. So I get the 1 times the 8, that's 8, added to 2 times 10, which is 20, and then 3 times 12, which is 36. When you add those together, you get 56 plus 8, which is 64, which is the number that goes right there. I'll continue with this one just to get the entire answer. This bottom left element is in row 2, column 1 of this matrix. So I take row 2 from the left-hand matrix and column 1 from the right-hand matrix. And I do 4 times 7, which is 28. I do 5 times 9, which is 45. I do 6 times 11, which is 66. And I add those together to get the answer, which is apparently 139. And finally, to get this bottom right, that's in row 2, column 2. So I take row 2 from the left-hand matrix, I take column 2 from the right-hand matrix, I multiply the first thing in that row by the first thing in that column, so 4 times 8 is 32. Second thing in that row times the second thing in that column, which is 50. Third thing in that row plus third thing in that column, which is 72. These become 104, plus 50 is 154, which was the answer to that question. So that's how you multiply 2 matrices together. Just for extra practice, why don't we do 1, 2, 3, 4 times 5, 6, 7, 8. Now, this is 2 by 2, this is 2 by 2. Because these numbers match up, we can multiply them, and the answer is going to be a 2 by 2. So it's going to have 4 slots. If you're teaching this lesson, have the class try to do this one. To get the top left one, we do row 1 times column 1. That's 1 times 5 plus 2 times 7 to get 19 is the top left element. To get the you can do these in any order, so I'll just go to this one. Row 2, column 1, I take row 2 with column 1, which is 15. This is row 2, this is column 1. So it's 15 plus 28, which is 43. To get this top right one, it's going to be, I'll just make a note here, this was row 1, column 1. This was row 2, column 1. Row 1, column 2, I take row 1 and I take column 2 and multiply them in that way. 1 times 6 is 6, 2 times 8, 16, added together, get 22. And finally, row 2, column 2, it's 3 times 6 and 4 times 8, which adds up to 50. As extra practice, we could do what happens if we multiply them with the 5, 6, 7, 8 on the left. You would find that you get a different answer. Back here we did it on the calculator and got 23, 34, 31, 46. 23, 34, 31, 46. And that would be a good practice question. The only other thing I want to mention is that there's a very special matrix that has a 1 here, a 1 here, and zeros everywhere else. So the main diagonal going from top left to bottom right is 1s, everything else is 0. It's kind of a funny matrix because when you multiply 1, 0, 0, 1 times 1, 2, 3, 4, you end up getting 1, 2, 3, 4. And that would also happen if I multiplied 1, 2, 3, 4 times 1, 0, 0, 1, I'd also get 1, 2, 3, 4. Well, this matrix has a special name. It's called the identity matrix. And it's kind of like the number 1 in math. 5 times 1 equals 5. In matrices, a matrix that has 1s across the diagonal and zeros everywhere else, when multiplied by another matrix, will give you back the same matrix, as long as you can multiply them together, which in this case we can. This identity matrix, we could do things with it, like if we add 2 of them together, we get 2, 0, 0, 2, which is kind of like saying 1 plus 1 equals 2. In that way, numbers are kind of like a subset of matrices, where this is kind of like the number 1, so 1 plus 1 equals 2. And numbers like this, that if I think of matrices, if they have zeros here and the same number across the diagonal, works kind of like a number. 2, 0, 0, 2 times 3, 0, 0, 3 would get us 6, 0, 0, 6. So it's kind of like 2 times 3 equals 6. That's just a little thing on the side. It's going to be important later. An identity matrix is identity matrix has to be square, meaning has to have the same number of rows as diagonals, rows as columns. And for 3 by 3, there's an identity matrix that looks like that. So it has to be a square matrix, same number of rows as columns, 1s down the diagonal from top left to bottom right, zeros everywhere else. Functions kind of like the number 1 in numbers. Okay, that's going to do it for lesson number 4.